Hi folks, this is just to let you know this is not a how-to video. Please, if you do any of this stuff, make sure you work safely, you do any of this at your own risk, do a lot of research and make sure you work very, very carefully because the voltages in this equipment is deadly and it can hurt you. 7.3 and let's get on with it. Hopefully I'll be alive at the end of this. Tubes, valves, thermionic valves, vacuum tubes, bottles. So what I'm going to be plugging into my inverter, 1955 edition of Popular Electronics, and I found without actually realizing that I actually have, I will show you. Booyah! It's a Tuesday, a very cloudy Tuesday morning, and it has arrived. A package from China, not on a slow boat from China. I think it's come airmail. It's arrived fairly rapidly, and this is all the stuff I'm going to need for my new project. So without further ado, we'll get into it. I'm very nervous about this because there are some things in here that don't like being smashed around, and I would have thought it would be in a solid box. So fingers crossed it's all survived the transit from China to Australia. From AliExpress, we have a number of items, and these are all going to be for the next project, which is going to be a vacuum tube CW, single tube transmitter. And I think this object here might be one of the first things that I'm going to need, and that is, yes it is a DC to AC inverter, a 220 watt DC to AC inverter. And the idea with this is I'm going to take my power supply in the shack, turn that DC to AC, and then rectify that AC. And in that way I've managed to provide some isolation for that plate voltage that I'm going to need to run the single tube transmitter. So that's the little inverter. It's a cute little thing. It's in a metal box, and there it is there. So we'll get that into another metal box. We'll double it up and we'll see if we can turn that into a power supply, along with a 6-volt supply for the filament, which I probably will use a 3-pin regulator for. So that's survived the trip. That's a good start. Let's have a look at what's in here. These are tube sockets. I only need one, but I got a lot of them. I just thought it would be nice to have more if I decided to build more vacuum tube type projects. And this, I am assuming, I'm hoping, is a vacuum tube. It is in a very well padded bag, so my trepidation may very well have not been necessary. But let's see if it fits in this tube holder. That's the next there you go. We actually managed to get the correct holder for the correct tube. A 6v6. Can't wait to get into this. I'm really excited. Tubes, valves, thermionic valves, vacuum tubes, bottles, call them what you want, they're my new obsession. Or should I say, my new old obsession. Now, viewers of this channel will know that I have an art background. High school art teacher, graduated National Art School many, many years ago in printmaking, love all things fine art, and hence the name of this channel, The Art of Engineering. Not because I'm an engineer, but I did start an engineering degree, hence the name of the channel. And I did about 18 months and decided that radio, which was a new obsession that started around about the same time, wasn't really a new obsession, it was a new old obsession, kind of like valves. Got back into radio after leaving the hobby probably when I was about 19 years old. got my novice when I was 13, went off to sea to become a radio officer, and that's why the hobby kind of ended, because doing radio for a job was not something that I wanted to do in my spare time. Fast forward 30 odd years, I'm sitting at home watching videos on YouTube, going down the rabbit hole of different things, and I find a Peter Parker video and some of the homebrewing stuff that he's doing. I think it was one of his little QRP transmitter videos, and I was hooked. I thought, wow, people are still sending Morse code. Got the license again, and a form of Renaissance, kind of like the artistic Renaissance. And just like the Renaissance, we look into the future and we innovate, but we also look to the past for inspiration. So at the moment, I am very, very excited about playing around with valve technology and maybe creating a marriage of more modern electronics with this electronics of the past. Let's go. This is the April 1955 edition of Popular Electronics. And I found this resource on the worldradiohistory.com archive, where you will find a heap of things. If you want to go down that rabbit warren of past technology and fun projects from the past, this will be the place you'll want to go. And how did I find out about this place and the transmitter I'm about to build? I'll show you right now.
Hi, this is Bob, and I had a really good time 2 weeks ago. My wife and I went to Colorado to visit our daughter, and she lives at 9,100 feet on the slopes leading up to Pikes Peak.
This is the YouTube channel of a Robert Sumption, and he was nice enough to share a transmitter that he had a lot of experience with as a youth and then recently resurrected, or reasonably recently. And so I'd never seen this transmitter, and I think this is the only place it appears as far as I can see on YouTube. So fantastic opportunity. And he's also the one that pointed me to that World Radio History website, which is also fantastic. While we're on YouTube, I'm going to show you another place, or another couple of places that you might want to visit. Now, this is Microwave 1 Mike, Whiskey Uniform 2 Delta, and what a fantastic site this is. He's building 1929 transmitters, he's building regen receivers, he's just doing really fantastic and fun stuff, and indicating, or at least pointing you in the direction of how to get stuff done. He will, of course, let you know that it's all at your own risk, which we need to say over and over again, because there are voltages in this stuff that can hurt you. So you really need to make sure you do your due diligence before you attempt any of this stuff. But yeah, Microwave 1 Mike. Check out his YouTube channel. I will put a link in the description below. And of course, if we're talking about valves, we have to talk about Mr. Carlson's lab. Fantastic YouTube channel and resource. And he does a lot of technical videos as well, telling you about how all this good stuff works. Check him out. Link in the description below also. And this is the magnificent Helge Fykse. I'm gonna mangle the pronunciation of his surname. Lima Alpha 6, November Charlie Alpha. And the videos are not in English, but you can get subtitles, and just an amazing array of videos and really, really fun projects. I'm gonna show you one very, very quickly. And this is a single triode CW transmitter. It's using an old World War II triode there. It's in a plastic plexiglass box with a what looks like a synthesized VFO. So just an amazing build. You'll find so much stuff on this channel to look at. The Hart 25 CW transmitter for 40 meters also could operate it on 80 meters, I'm sure. Now this comes care of that issue of popular electronics from the 50s, like I just told you. And what we're going to be doing is we are going to be removing this part of the circuit here. So a lot of people are roadblocked from building this sort of stuff by the fact that they need to source themselves a transformer. And I'm going to show you a couple of roadblocks in the process of building a tube transmitter that you can get around. So I've already gotten around one of those roadblocks, and that is finding tube sockets and valves. Now, will this valve work? We're going to find out. But I bought a 6V6 from China, from AliExpress, and I also got myself some of the tube sockets that are required. So we've crossed that bridge, we've got that done. Now these capacitors that are in here, They need to be 600 volt capacitors. You'll be able to get those through Mouser or places like that. I actually had 2 capacitors that were the correct value that are for a cage repair in the TS520 from when I was resurrecting the TS520 and changing the final stage in that and the valves in that. So I've had a little bit of experience now with playing around with this stuff, and it's just made me want to play with it more. So what's going to happen is we need 300 volts or so to run this tube. So what we're going to do is we're going to use the Shack 12 volt supply, feed it into an inverter to make it to 230 volts, which will give us a level of isolation rather than running it straight from the mains, which I'm not a fan of. So we'll have a little bit of isolation via that inverter, and then we will rectify it to give us our 300 odd volts of a DC to run the plate. And I've got a 3-pin 6 volt regulator to provide the voltages that we'll need for the heater. So the first stage of this whole process is procuring parts. Now, another thing that's becoming a lot more difficult to procure is our RF chokes. The RF chokes seem to be quite hard to come by, plate chokes and whatnot, pie chokes, but you can wind them yourself. And I've found this out care of the Arrel handbook, of the more ancient Arrel handbook from the 1930s, I think. And I found all this information out via, once again, Mike, Whiskey Uniform 2 Delta, and his wonderful channel Microwave 1. And so he actually has a video where he gives you the lowdown on RF chokes and also how to make your own as well. So it's a great channel, and once again, I will definitely point you in that direction. So I'm going to have to make this coil here and also this RF choke, and that will be definitely in this video. I'm also going to show you the parts, because when you start trying to build one of these radios, the first thing you need to do is start to collect parts. So this box, it kind of looks like, almost like it's the right vintage for an old valve transmitter, and it's actually from IKEA. I guess it's like a biscuit container, and it's metal. So we should be able to scrape back some of that enamel to get a good surface that we can bolt to for earths and whatnot. This is an old switch mode supply, and you might be wondering why I've got this. It's come out of the junk box. I think it's from an old modem. That capacitor, and quite often the switch mode capacitors have a very high voltage rating. This has got a 450 volt rating, so I'm going to use this to filter the DC that's coming out of the inverter that will be providing the 300 volts for the plate. So over here on the plate of our 6v6, you're going to need about 300 and a bit volts. So this voltage needs to be filtered, and that's going to be filtered via that capacitor. So that's one thing we're going to need. I went and got lots of wire. Now, I would not advocate going to JCar to buy this stuff because it's quite expensive, but it is convenient. And do you save money? You might actually be better off shopping around and getting an RF choke, a pie choke, which is broader bandwidth. But I like making this stuff anyway, so I'm going to have fun doing that. A whole heap of crystals, care of my mate Victor Kilo 2 November Alpha Papa. Some of these disc ceramics that need to be high voltage, like I said, they're Kenwood cage repair ones, and they're 2 kilovolts, so they're more than high enough. You probably get away with like 500 or 600 volt capacitors. Now, I have a couple of BNC connectors, chassis mount connectors, and the reason why I've got 2 of these is because I plan to switch from receive to transmit and have the one of these feeding the receiver and one going to the antenna. So that's why we're doing that, and that's care of the way I did it in a previous build that I did. Worked reasonably well. Now these tag strips, old school, I got these at JCar, would you believe it or not? So I've got a few of those. I may or may not need them. I like to buy stuff in case I'm going to need it, and if I don't, I just put it aside and use it another time. Now, the design for this transmitter uses a lamp to tune for maximum transmission. I'm going to be feeding it through my antenna tuner anyway, so I'll have a power meter, but I will have this little LED, and it will be fed by a little inductor. So we'll be able to see it flashing when we transmit. I think that's a cool thing to do. And I've got one that's in a little bit of a bezel to give it a little bit more of an old school look. So that should be fun. our 3-pin regulator for the 6 volts for the heater. Fuse holder, so we're going to fuse it somewhere so we don't have an overcurrent situation. This is a 12 volt jack that's going to allow me to use the normal plugs that I use for my power supply on the bench. Assorted resistors that are required, an earth lug so we can earth the thing, a key jack. Now the key jack needs to be open circuit. I'll just get a bit more light on things here. It needs to be open circuit when it hasn't got a key in it, otherwise the thing will be transmitting continuously. So I've checked that, it's all good, I've metered it. Now the Vero board, now I could use this for various things, but one of the things I am going to need it for is I needed some way of being able to mount crystals. I don't want to use another socket because I'm not using the large style crystals. So I am going to be using a couple of those little connectors that you use for mounting ICs. And this is perfect for plugging in a crystal. So that's how I'm going to plug my crystals in and out. So you're thinking about all these things, and obviously there's things you'll miss and you'll have to come back to. I bought a few of these little jacks because I use them all over the place for various projects that run off the shack supply. More resistors, wire round resistors. Now I couldn't get the value I wanted, so that's another reason. People say when they're doing their amateur license, why do I have to learn all this Ohm's law? Well, if you want to be able to find parts that fit a particular design and you haven't got the exact values you need, you can use Ohm's law to calculate what you do need. And we have a bridge rectifier for rectifying our inverter output, and that's a plug should I decide to make another lead, but I've got so many on the bench now. A couple of fuses are in here, and I got myself this chunky transmit receive switch, and what that will do is I plan to switch the antennas on this from receive to transmit, but I also I'm going to put this in the key line as well, so that when we're not in transmit, if I accidentally hit the key, I'm not transmitting into my receiver, because that would be a bit of a disaster. Couple of fuses, and you may be asking, where is the main event, the vacuum tube? Well, we saw that at the beginning of the video. We have a small inverter for a car that will go in here. That'll provide me with 220 volts, which will multiply by 1.414 to get us up to 300 and something. I can't do the maths in my head. And then we'll be rectifying it and using, like I said, that filter capacitor from that switch mode supply. And look, the supply should be reasonably clean after that, but we'll find out if we need to add anything else or more capacitance. Time will tell. Oh, nearly forgot one last thing. Went to Bunnings, got myself a length of PVC pipe, about 1 1/4 inch it is, and I bought these ends as well because the plan is I can actually bolt one of these on the lid. That's my lid here. Bolt it to the lid, put necessary holes to run leads through and whatnot, and then my actual coil can sit inside that and be glued into that. So my transmit coil and my RF choke will be living on top of here with the valve. We won't need a transformer. The actual inverter will live inside the box. Well, we have started the process of the build, and I'm going to be soldering this into the board so that we've got something to hold our crystal. And I've just gone through the junk box. God, it's good to have a good and well-stocked junk box. A lot of the time they send you plugs for other countries and people throw them away, and you can do that if you don't want junk all around the shack. Now, this had an earth pin on it, and if I was going to be using it, obviously I wouldn't advocate removing the earth pin, but for the purpose that I'm going to put it to, it won't be an issue. So what I'm going to do is I'm going to strip this cable back, find those two cables, because those two cables are going to be what I'm going to be plugging into my inverter. And the inverter will be sitting inside the box, and so none of this is going to be exposed. It's going to be plugged straight into, hardwired or soldered into the actual transmitter. So internally I will be able to plug and unplug this inverter. I think that's a nice solution to getting the power from this to the bridge rectifier, and then from the bridge rectifier we'll see what we're going to do with that. These will pass to the jack at the back, and I would like to be able to bolt this case to the bottom of the actual case the transmitter's in. Bit of progress. We're going to mount our coils in here. This has been a game changer. Step drill. Bought it at the Crazy Dollar Shop. Not the drill, but the actual step. And yeah, it's like reaming out holes and whatnot. Makes life so much easier. I don't know how long it'll last, but certainly on this soft stuff. I do have to be a little bit careful because I am already starting to make this look like Fred Flintstone type construction, but that is the hole now that I'm going to mount my beautiful vacuum tube in. Now I've set it back a little bit because I'm kind of having to be aware of what's going on inside the case, and I'm going to have a couple of air variable capacitors living around here, so I don't want to sort of be conflicting with all the wiring that's happening over here. So we're just going to have to like be mindful of space inside the box. I think considering there's no power transformer, this box should be plenty big enough. Fingers crossed, because there's not much planning happening. And there you have it, folks. All the cutting, as far as I can tell, and drilling and whatnot that needs to happen on the top of the lid. As you can see there, you know, we've made a bit of a mess of the top. You know, tried bashing it straight, bit of panel beating happening, but it'll all add to the 50s charm of this rig, I am assuming. And you know me, rough and ready is the way to go, as long as the thing operates well. Hey, sometimes it doesn't even operate well. So that is the top. We will now wind the coils, and that's going to take quite a while, especially the RF choker. We need about 150 or so turns on that, and we'll get that all wound up, and the transformer for the output. And we are well on the way to getting this thing done, but I might have a go at all the drilling and whatnot that needs to happen, the metalwork that needs to happen while it's daylight, because we don't want to be drilling at night time and annoying the neighbours. And as bad luck and stupidity would have it, I paid like $9 for this tiny little length of tubing. They really see you coming at Bunnings without actually realising that I actually have, I will show you, this probably 3 or 4 metre length of the same diameter tubing that I was going to use for repairing antennas. So it pays to have a good look around. Anyway, we will use it at some point in time when something breaks. We will turn it around and cut the other end, because then we've got at least one end that's flush, and that means that we can hide any, you know, stuff-ups in the end caps. So what we're doing is, I actually have this little resin bonding. I was going to try super glue, but I was worried the super glue might react with the actual substance on the actual coil, and I'm hoping this doesn't, so we'll find out if it compromises the enamel when this thing catches on fire. But yeah, you can use a little UV light to harden it up, and every few turns I've just given it a blast and stuck it in place. Now this is about 135 turns on that 40mm PVC pipe, so if this works for this transmitter, we'll know that it's an adequate RF choke, and if it doesn't, we'll know it isn't. Isn't that great? What a beautiful thing. Oh, nearly forgot to mention, I ended up just sticking a screw in this board, and that just gave me the opportunity to pull the wire off and not have it go everywhere. Worked all right. All that winding, over 130 turns of 0.5mm wire, and we're only at 0.34 millihenries. That is extremely disappointing. Now, I'm getting to the point where I'm thinking perhaps making your own is not as cheap an option as one would think, unless you've got lots and lots of wire lying around. You could make this about, say, that long and wind it all the way to the top, but I'm going to try and come up with an easier solution. I think what I'm going to do is I'm going to grab one of my larger ferrite cores, and wind that up and see whether I can get enough extra, because we need at least 800 microhenries, which would be 0.8. That's the minimum we're looking for. And down the rabbit hole we go. VK4PK, winding toroids. Isn't it wonderful how technical a hobby this is? This is the T200-2 data sheet. We have an AL of 12, and it's good for 250 kilohertz to 10 megahertz, so we know it's good. I have one of these toroids. I bought it for another antenna project that has been put on hold, so I'm going to use this and use it judiciously. I think it's going to cost me a fortune in wire, because I have gone into the please excuse the handheld filming. I've gone into, I just want to share all this stuff. I've gone into the required formula to use that. So we put our desired inductance in nanohenries over our AL value that we got from that data sheet, and we put it all to the power of a half. Now, for all you maths challenge people like me, I'm going to explain what that means right now. So our core is a 0.35 millihenries, and well, it was 0.34 before, so let's go with 0.34. So we need to say 0.8 millihenries because we need 800 microhenries. So 0.8 minus 0.34 will get us to not 468, because Jesus, you're an idiot, 460, which is in nanohenries from that formula that we just looked at, 460,000 nanohenries. And we divide by the AL value for our toroid, which is on that data sheet. I'll show you again. Where is it? It's just there. AL equals 12. So we're going to say 460,000 divided by 12, and to the power of a half is a square root. And that gives us a very big number. I think it's 196. Well, we have only just managed to get there, 0.46, which is going to get us, which is 460 microhenries, which is exactly what we need to make the 800 microhenry total when we series it up with this. So, boy oh boy, I think it might have been cheaper just to go and buy a damn Pi RF choke, but then we'd have to wait, and we'd lose the opportunity to have all this fun learning about how to wind a choke on a toroid core to a specific inductance. So hey, this is what it's all about, guys. Home brewing, home rolling, having fun. Now, I could have used a much lighter wire than this so that I could have got way more windings on, and that would have also solved this dilemma. So probably next time, use a lighter gauge wire. Mike on Microwave 1 did tell us to do that, and then I just grabbed the first roll of wire I could see and then spend the rest of the day winding coils. But wait till you see how I'm going to get this all married together. It's going to be hilarious. So we've got our RF choke done. In this actual design here, it's actually got 2.5 millihenries. So if I wanted to make that 2.5 millihenries, I'd be here forever. I'm going to go with the value of choke that I found elsewhere that should do fine. We will find out if it works. And we are going to now wind the plate, choke and antenna choke. It's a transformer really. And I'm going to read what we need to do here. For the 7 megacycle band, which is what we're building this rig for, we need, the plate coil is 16 turns of number 20 enamel, and it's spaced the diameter of the wire, which is 0.8 millimeters, so it's about a mil between each winding. And the antenna coil is 13 turns of number 20 enamel close wound wire. So that is what we're going to be doing. I'm pretty sure it goes antenna bottom and the plate at the top, but we will have a look online at the other examples that are online and make sure that we're right about that. And that will be us done with everything we need for the top of this transmitter. And I'm getting extremely excited about this. Well, at this point in time, I am just trolling the internet, Microwave One's website, and various other sites as well. This is probably a nice place to leave part one. We have completed the top of the transmitter. We have our very hard fought for RF choke, which we still don't know whether it's going to work. We've got a holder for the crystal. We don't know if it's going to blow a hole in this crystal. I have looked on a few websites, including Microwave One, to see how we can perhaps mitigate that issue. But I may be in the market for a bigger crystal at some point in time, or we might go for some sort of external DDS type synthesis of a crystal. We'll have to have a look and see what's going to happen on this front. Maybe even the QRP Labs Prog Rock, maybe, I don't know. But that's a possibility for stimulating this tube. And of course, we've got our beautiful LED. I think it's a blue one in a bezel. And that will flash when I'm transmitting. So that is the top of the transmitter. Stay tuned for part two to see whether I actually get this thing to transmit and get it on the air.